Hi, I'm Ms. Holben. If you're watching this video, it's because you missed the last day of your Algebra 2 class, where we actually did something a bit different than what you normally do in class. We started a computer science integration project, or also known as CSI. Not the fun kind of forensics and things, but the fun kind of computer science. For some of you, this might actually be your first CSI project. For some of you, you might have done one of these or heard or seen me before. So, what's the point of CSI? Well, Sacred Heart has decided that it's important for you to be able to learn a little bit of computer science. Computer science is used in every single industry, from science to business to fashion to photography. So it's really important for everyone to be able to understand at least a little bit of coding, whether you decide to actually pursue computer science or not in your job. You might be asking yourself, if we're going to be coding, why did I have you actually bring your calculator? Hopefully you have your calculator with you, your TI-84. Your TI-84 calculator is actually really powerful. It's actually over 10 times more powerful than the computers that sent Apollo 11 to space. Now, that doesn't mean your calculator is going to take you to the moon, but one of the things that you may not have known about your calculator is that it has a built-in programming language that we are going to use today to do some interesting things. We're going to start this by thinking about what actually is a program. We're going to think of a program as a series of commands, the same way that when you bake a recipe, maybe you're baking some cookies, it's made up of a series of steps. We're going to be writing our programs in TI Basic. That's the language that our calculators use. It's TI Basic. We have an idea of a program as a series of steps, but what does it mean that our calculator uses TI Basic? What is this programming language? I mentioned that your calculator uses this one, but what does that actually mean? Well, in the same way that you're able to read, understand, and speak English, computers have languages that they're able to read and interpret. If you think about what it means to actually know a language, what do you have to be able to do? First is you need to understand the vocab. And what I mean by vocab is, what do the words mean? TI Basic has a pretty short vocabulary, but there are certain words and commands that mean specific things, and we're actually going to learn what those are today. The second thing that you have to do is understand the grammar, or what's commonly known in computer science as the syntax. This is kind of the idea of what order do things go in. This is something that we'll need to learn because it's going to take some getting used to. This is going to be pretty new. In some languages, it doesn't actually make a huge difference what order things are in. If I'm going to give an example in English, let's say I could say the sentence, my favorite subject is algebra. I could also say the sentence, favorite my subject algebra is. And I might sound a little bit like Yoda, but hypothetically, you should still be able to figure out and mostly understand what I'm saying. But computers are more finicky than humans. They're not really all that flexible about things like that. And they don't have the ability to figure out errors in grammar or syntax like humans do. So it's actually really important that we have all of our commands and the things that we're typing in the right order. The third thing is we use language to actually articulate or say or describe ideas that matter. And the whole goal of today is how do we actually put together TI Basic commands in a way that actually does something useful and interesting. Now, there's going to be a few things that are really important in this video. The first thing is that at all times, you need to be following along with exactly what I'm doing. I know you can't see me because I'm just a disembodied voice in a screen, but I'm going to be doing things and typing on my screen, and you should be following along and doing the exact same thing. So when I type the letter A, you're also going to type the letter A. The second thing is that if you happen to fall behind, make sure you pause this video and stop and double check with yourself that you understand what's going on. Pause me if you need to. That's totally fine. On the other hand, if you feel like I talk slow and you're getting really bored, put me on 2 times speed. That's also fine. I promise I won't be offended. I promise I will not even know. All right, we're going to get into it. So it might seem a little daunting to jump right in, but that's what we're going to do, is we're going to jump right in. And our first program is actually only going to be 4 lines of code, so it's really not that crazy. So to start, we're going to write a program that actually computes the area of a cylinder. Now, for some of you guys, it might have been a minute since you thought about geometry or shapes or anything like that. You know, Algebra 2, you're so beyond geometry. So let's think about what this actually means to find the area of a cylinder. If you remember how, honestly, kudos to you. I definitely would not have if I were in your shoes. All right, well, here's our cylinder. And if I'm looking for the surface area of this cylinder, isn't the surface area just a circle here, and kind of this middle part here? So what's that actually going to be? Well, if we think about what the surface area of a circle is, isn't the area of a circle just pi times whatever the radius of the circle is, actually squared, right? Pi r squared is what we usually think of. So I'm just going to rewrite this as pi r squared. And we actually have two of those. What about the area of the middle part? Well, the area of the middle, that kind of part that wraps around in the center here, isn't it actually the circumference of one of these circles times the height? If you think about it, it's kind of however many circumferences all the way down, and that's how I get the surface area. Well, circumference is just 2 pi r. So let's do 2 times pi times r. That's the circumference. And then this distance, usually we think of this as h, or the height. So if I have that as the area of the circle and this as the area of the middle, then shouldn't my total area actually be 2 of the area of the circle plus the area of the middle part, which is 2 times pi times r times h? So you can see this is kind of a crazy way to look at it, but this is going to be our formula. It's going to be 2 pi r squared plus 2 pi rh. What values do I actually need to know to be able to calculate this is I need to know a radius and I need to know a height. All right, now that we've thought about that, let's actually think about how to make it as a program. So let's get into it. Before this Algebra 2 class, I actually had you download an app onto your computer called TI Connect. We're going to use this app to write our code in. Before this app existed, you actually had to punch in every single letter of code individually on the calculator, which unsurprisingly takes a ton of time to do. So it's a lot faster and less painful now that we don't have to do that. We're going to go ahead and open the app. It looks like this on mine. If you don't see it in your dock below, you can do the thing on a Mac where you do Command Space and search for TI-Connect. And it should pop up. You could do a similar thing on Windows where you explore and try to find it. So I'm going to open it up. Takes a little bit to open. TI Connect's just a little bit slow. And now that we have this open, to make a new program, you have to click this button on the side with the 3 boxes. And then you're going to click this big plus that says New Program. The very first thing you always want to do when you make a new program is name it. And you have to do it actually in this bar up here. So we don't want it to be called Prog01. That's a terrible name. We're going to call it SACYLIND. And what does that stand for is surface area of a cylinder. SACYLIND. Once we've got this down, let me show you a little bit about how TI Connect works. On the left side over here is our toolbar. There's all these different drop-down menus, and all of them have hidden TI basic commands in them. So you can see if I open up the keypad, here's actually all of the buttons that are on your calculator. You might recognize some of these. There's a lot of other menus that do plenty of other things. Look, there's a finance menu. How fun. We're going to spend a lot of time in the keypad menu and a lot of time in this program menu here. These are all the things that are kind of TI basic specific commands. On the right side here, this is our coding window. Any code that gets typed here or added in here is actually a part of our program. And this here is what's eventually going to get uploaded onto our calculator to actually run. We're going to start by putting in our first command. So let's go to the program menu. It's in the input/output, and the one that we're going to use is this command called prompt. Prompt lets me ask the person who's using the calculator to give me some numbers for some variables. And if we think about the problem of solving the surface area of a cylinder, what values did I actually need? Didn't I need a radius and a height? Let's finish this line by adding in r, h. Those are the two values I need. So what does prompt do? I'm prompting the person who's using the program to give me numbers for those values. Now, r and h are what we're going to call variables. Variables in computer science are a little different than variables in your math class. So here's what I want you to be thinking about. R and H essentially act as storage containers for some number that's going to go in. And here's the picture that I want you to have in your brain. R and H, like I said, are storage containers or boxes. Each one of those can get some sort of value. One of my favorite things about computer science is if you're not sure what something does, you can always just run your code and see what happens. Now, just to save on time, I'm going to run this code on my calculator, but I don't want you to necessarily follow along. But I do want you to pay attention to the steps I'm going to take to do this, since you're going to have to do them soon. I first have to make sure my calculator is plugged in and on. And if it's plugged in and on, I should be able to do this. You see all the way on the top here where I have this little button that looks like an arrow pointing into a calculator? That's actually the button we're going to use to, send a program to a connected calculator. So let's click this. And you'll see that if I have my calculator connected and on, it'll actually pop up as an option. And I can click send to actually send this through the wire onto my calculator. Now, you won't see any physical change on your calculator when this is done, but here's what you want to do to actually find your program. On your calculator, you're going to click the button that says PRGM. It's towards the middle of kind of the darker buttons on the top of your calculator. When you see that, most of you guys will not have any programs in your calculator. I might have a few because I've coded a couple. In this menu, this is what allows you to run one of the programs. So let me find my SACYLIND program. I'm going to hit enter. That cues it on the screen. I'm going to hit enter again, and look, it's asking me for a value for R. Let's put in 2. And look, it's asking me for a value for H. Let's put in 5. And look, it says done. So what did that program actually do? It asked me for a value for R, it asked me for a value for H, and then did nothing else. And why is that the case? Well, look at our code. All it actually does is prompt me for a value for R and H. I do want to talk a little bit about what's happening though when we do that. When I prompt the person running the calculator for a value for R and H, what's happening on my calculator is that I have these boxes. Like I said, R and H are both boxes, and what happens in the box for R is I'm going to put in the value 2, and what happens in the box for H is I'm going to put in the value 5. So now these numbers are stored in the boxes labeled R and H. All right, well, now clearly we have to do something else. What do we want to do with R and H? Well, we want to use them to calculate the surface area. So let's put in the formula that we figured out before, 2 pi RH plus 2 pi r squared. Don't feel bad if it feels like you're kind of working through this pretty slowly. We are kind of coding in this little annoying environment, so it's not the end of the world. So 2 you can just type, times, you might be wondering how you get pi. It's actually at the top in the keypad menu. If you scroll down far enough, there it is, there's the pi, times r times h. And yes, you do need to do all of the multiplication symbols between these. Often in your math class, you might write this as times RH. That's something called implicit multiplication, which means that we know in the rules of math, when I write 2 variables next to each other, I'm actually multiplying them. But remember, we're working with a different language now, and each of these languages has its own syntax or rules I need to follow. And one of the rules is I actually do have to put in these multiplication symbols. Plus 2 times pi times, you might be wondering, how do we do r squared? The easiest way to do it is just do r times r. Now we've made this calculation. Hypothetically, this should be the surface area right here, but I actually need to put this value in something. Maybe I need to put it in something that's like a box. Let's store this value in a variable. We're going to call it A. A, of course, stands for area. To do this, I need to add a little arrow. If you scroll up to the top of the keypad menu, it's actually the second one here. And what I'm doing is I'm putting this value in the box labeled A. Again, that's all a variable is. Let's do one more line in this program because right now I've calculated this wonderful surface area. I've stored it in my variable, but guess what you'll see when you run your calculator is nothing. If I want to see something, I actually have to tell my calculator to display something on the screen. Let's close out of the keypad menu. Let's open up the program menu. And in the input-output, the third command down is this command called disp, which stands for display. What do we want to do? We want to display the area, or A. Once you've got these 3 lines of code, let's go ahead and actually upload this onto your calculator. So again, I want you all to follow along now. Hopefully you have a calculator cord. If you don't, just watch and trust me that this will work. You're going to click the button to upload. Uh-oh, my calculator accidentally turned off, so I'm going to make sure it's on and plugged in. There it is. I can check the box, and I can send this on to my calculator. And now let's actually try running this program with 2 and 5. And you should get something on the order of 87.9645943. I think that's actually exactly what you end up getting. Congrats if you did get that. If you didn't, again, go ahead, double check every single thing you typed with every single thing that I've typed on my screen. Now, there's one thing that I don't really love about this, which is that in your geometry class, that's usually not how your teacher would have you write your answer. Wasn't it pretty common that for a lot of these shapes that kind of had to do with circles, instead of writing just this crazy gross number, you would actually leave your answer in terms of pi? Let's actually change our program to be able to do that. First, there's 2 things I have to do to be able to do that. The very first thing is let's get rid of the value pi in the formula. I don't want to actually multiply by pi if I'm going to say that it's 3 pi at the end of the day. So let's get rid of the pi here. And let's get rid of the pi here. Then in my display line, I actually want to add the pi symbol. Now, there is a way I can actually do this in one line, but it's a little easier to just do a completely separate display. So I'm going to do another disp down here. Let's do quotations, the pi symbol, and quotations. I promise I will talk about why this is the case, but for now, I just want you to do kind of exactly as I do. Again, we'll see why in a second, but for now, we do need to put the quotations around the pi. I'll explain too. All right, it's time to run it and see what happens. Let's re-upload this to our calculators. It'll overwrite the one that was on there, and you should let it overwrite. And let's run the program with 2 and 5. And that looks good. Now, it might seem a little bit funny to you that the calculator prints out the number and the pi symbol on opposite sides of the screen, but that's just how the disp command works. For our purposes, we're not really going to care about it. But if it does annoy you and you'd like to make it look a little nicer, feel free to come talk to me later on in a different day, maybe office hours or something. It is a little bit more of a pain than you actually think to get the formatting right. Now, I want all of you guys to actually put down your calculators. So if you're watching this right now, take a second and just watch what I'm doing. I'm going to change my program a little bit, but I want you to keep yours as it is. And I want to show you what happens if I actually run this without the quotation marks here. So I'm going to get rid of the quotation marks around the pi, and I'm going to re-upload this. And let's go ahead and run this again. Again, I'm going to do it with 2 and 5. Now, what do you notice? It's actually printing out the numerical value for pi, which is a little funky. What you didn't know about the pi symbol is that it's actually a variable too. So when we have this picture of variables on the screen over here, we're actually missing another one. That's going to go right down here. And what's going to go in here is pi. And what's going to go in the box is the value for pi. So like 3.14159.2 ... Now, what's important about this is the idea of when do I and when don't I use quotations. And this visual is really important. When you use quotations, you're going to get the name or the label or the symbol, however you want to think about it. Essentially, what you'll get is what's on the left side of all of these boxes. If you don't put it in quotations, you're going to get the value, which is what's actually in the boxes, or on kind of the right side here. Think of this sort of like a moving box. If you've ever moved before, you know that you put a bunch of stuff in cardboard boxes, and oftentimes you'll write what's in the box on the outside of the box so that you know what to unpack in what order. You send the kitchen stuff to the kitchen and the bedroom stuff to the bedroom, yada yada, all of that. Now, if I asked you, hey, what's in the box? Probably the logical answer would be to tell me the name of the label, not to hand me the value of what's in the box. The question of what's in the box, what I'm expecting is actually the quotations. I'm expecting the label or the name or the symbol. That's very different than the question, hey, hand me the thing in the box, which maybe would be some dishes or a comforter or something like that. What if I change this A to be put in quotations and I send this to my calculator? What am I going to see now when I run this? Well, we just said that when I put quotations around something, I see the label for the box. So when I run this, I actually will see the letter A, which is not actually what I want. So it's really important to remember when you want to use quotations and when you don't. In this case, I don't want quotations around the A because what I want is actually the numerical value that I calculated for A. But I do want quotations around the pi because what I wanted from this is actually the pi symbol. Again, putting quotation marks around something when we're displaying it on the screen will make it display exactly as is. Whatever is inside the quotation marks is exactly what we'll see. If we leave the quotation marks off, then the program displays the value associated with that variable or symbol. This is all the code that we're going to write for our first program. You did it. You wrote your first TI Basic program. Before we jump into the next one, I do want you to think about what we just built. Finding the area of a cylinder is actually a really good problem to code because there's pretty clear inputs and outputs. What do I need to find the area of the cylinder is the radius and the height. And what does it give me is the area. But aren't there also lots of different times where your math teacher might give you actually the radius and the area and ask you to find the height, or maybe give you the area and the height and ask you to find the radius? Remember, our program actually does one very specific thing. And if you wanted to solve one of those other problems, you would need to write completely different code to do that. In the next video, you will see the next example that we're going to do, which is going to be a little bit more involved than this one.